Hello everyone, and welcome. In this video, we're diving into the world of three-dimensional geometry to explore the total surface area of a cone. A cone is a three-dimensional shape with a circular base that tapers to a point known as the apex or vertex. Understanding how to calculate surface area is useful in many real-world applications, from construction to manufacturing. We'll break down the formula step by step and work through examples to make sure you grasp the concept fully. By the end, you'll be confident calculating surface areas for any cone you encounter. To understand the total surface area of a cone, we first need to break down what surface area actually means and identify the key components that make up a cone's surface. Surface area is simply the total area that covers the outer surface of any three-dimensional object. For a cone, this outer surface consists of exactly two distinct parts that we need to understand. The first component is called the curved surface area, also known as the lateral surface area. This is the sloped, curved part of the cone that extends from the base up to the apex or tip. The second component is the base area. This is simply the area of the circular bottom of the cone. It's a flat, circular surface that forms the foundation of our cone. Now there's one more crucial measurement we need to understand: the slant height. The slant height is the distance from the apex of the cone to any point on the circumference of the base. Notice that the slant height is different from the regular height of the cone. The slant height follows the slope of the cone's surface, while the height would be a vertical line from the apex straight down to the center of the base. So to summarize, the surface area of a cone consists of two parts: the curved surface area and the base area. The slant height is a key measurement that helps us calculate the curved surface area. Now that we understand the components of a cone, we can explore the formula for calculating its total surface area. The total surface area formula combines two distinct parts of the cone. The total surface area formula for a cone is TSA equals pi r squared plus pi rl. This formula has two distinct parts that we need to understand separately. The first part, pi r squared, calculates the area of the circular base of the cone. This is the flat circular surface at the bottom. The second part, pi rl, calculates the curved surface area of the cone. This is the slanted surface that wraps around from the base to the apex. We can also write this formula in factored form as TSA equals pi r times the quantity r plus l. This form is sometimes more convenient for calculations. Now, what happens when you're not given the slant height directly? In many problems, you'll only be given the radius and the height of the cone. In these cases, we can find the slant height using the Pythagorean theorem. The slant height L equals the square root of h squared plus r squared. This creates a right triangle where the height is one leg, the radius is the other leg, and the slant height is the hypotenuse. This relationship allows us to find any missing dimension. So the complete formula, when slant height is not given, becomes TSA equals pi r squared plus pi r times the square root of h squared plus r squared. Remember, the key to using this formula correctly is identifying which measurements you have and which you need to calculate. The radius and either the slant height or the height are essential for finding the total surface area. Now we're going to discover where the total surface area formula actually comes from. The key insight is to visualize what happens when we unfold the cone's curved surface. Imagine we have a pair of scissors and we make a single straight cut along the slant height of the cone, from the apex down to the edge of the base. After making this cut, we can now unfold the curved surface of the cone. Watch as we flatten it out completely. What we get is a sector of a circle. The radius of this sector equals the slant height of our original cone, which we call L. The arc length of this sector corresponds to the circumference of the cone's base, which is 2 pi r. Now we can derive the formula for the curved surface area. The area of any sector is given by 1/2 times radius squared times the angle in radians. But we can also express this using the arc length. Since arc length equals radius times angle, we can substitute to get 1/2 times radius times arc length. For our cone's unfolded surface, the radius is the slant height L, and the arc length is the base circumference 2 pi r. Simplifying this expression, the 2 and the 1/2 cancel out, giving us pi rl for the curved surface area. Finally, to get the total surface area, we add the area of the circular base, which is pi r squared, to our curved surface area pi rl. We can also factor this expression to get pi r times the quantity r plus L. This visualization shows us exactly why the formula works and makes it much more intuitive to remember. Now we're ready to solve our first example problem. We need to find the total surface area of a cone when we're given the radius and slant height directly. Here's our cone with a radius of 5 centimeters and a slant height of 10 centimeters. The radius extends from the center of the base to the edge, and the slant height goes from the edge of the base to the apex of the cone. Let me clearly identify our given values. We have a radius of 5 centimeters and a slant height of 10 centimeters. These are the two key measurements we need for our calculation. Now we'll use the total surface area formula. Remember, TSA equals pi times r times the quantity r plus L. This formula combines both the base area and the curved surface area of the cone. Now I'll solve this step by step. First, let me substitute our known values into the formula. Step 1, I substitute r equals 5 and L equals 10 into our formula. This gives us TSA equals pi times 5 times the quantity 5 plus 10. Step 2, I simplify what's inside the parentheses first. 5 plus 10 equals 15. So now we have TSA equals pi times 5 times 15. Step 3, now I multiply 5 times 15, which equals 75. This gives us TSA equals 75 pi. Step 4, our exact answer is 75 pi square centimeters. To get a decimal approximation, I multiply 75 by 3.14159, which gives us approximately 235.62 square centimeters. Notice that I always include the units square centimeters in my final answer. So our final answer is 235.62 square centimeters. This represents the total area of material needed to cover the entire surface of this cone, including both the circular base and the curved side surface. Remember the key steps. Substitute the given values into the formula, simplify step by step, and always include proper units in your final answer. This systematic approach will help you solve any cone surface area problem confidently. Now we'll work through a slightly more challenging problem. We need to find the total surface area of a cone, but this time we're given the radius and height instead of the slant height. Here's our cone with a radius of 3 inches and a height of 4 inches. Notice that we don't have the slant height yet, which we need for our total surface area formula. The first step is to find the slant height using the Pythagorean theorem. Remember, the height, radius, and slant height form a right triangle. We use the Pythagorean theorem, L equals the square root of h squared plus r squared. Now we substitute our values, h equals 4 and r equals 3. 4 squared equals 16 and 3 squared equals 9. 16 plus 9 equals 25. The square root of 25 is 5, so our slant height is 5 inches. Now that we have all three measurements, radius, height, and slant height, we can calculate the total surface area. We use the total surface area formula, TSA equals pi times r times the quantity r plus L. Now we substitute our values, r equals 3 and L equals 5. 3 plus 5 equals 8. Pi times 3 times 8 equals 24 pi square inches. If we want a decimal approximation, we multiply 24 by pi, which is approximately 3.14159. This gives us approximately 75.40 square inches. Notice how this problem required an extra step compared to our first example. When we're not given the slant height directly, we must calculate it first using the Pythagorean theorem. This is a common situation in real-world applications where we typically know the height and radius of a cone, but need to find the slant height to calculate surface area. Now that we understand how to calculate the total surface area of a cone, let's explore the many practical applications where this knowledge becomes essential in real-world scenarios. One of the most common applications is in manufacturing traffic cones. Companies need to know exactly how much reflective material and plastic they need to produce each cone. Consider a standard traffic cone with a base radius of 15 centimeters and a height of 45 centimeters. The manufacturer needs to calculate the surface area to determine material costs. First, we calculate the slant height using the Pythagorean theorem. The slant height equals the square root of height squared plus radius squared. Now we can calculate the total surface area using our formula. The total surface area equals pi times radius times the sum of radius plus slant height. This means each traffic cone requires approximately 941 square centimeters of material. For a production run of 1,000 cones, the manufacturer needs nearly 30 square meters of material. Another important application is in architecture and construction, particularly for conical roofs. Architects and contractors need precise surface area calculations to estimate roofing materials. Consider a conical roof for a tower with a base diameter of 8 meters and a slant height of 6 meters. The construction team needs to know how much roofing material to order. For roofing, we typically only need the curved surface area since the base is not covered with roofing material. The curved surface area equals pi times radius times slant height. The roof requires 75.4 square meters of roofing material. Adding a 10% waste factor for cutting and installation, the contractor should order approximately 83 square meters of material. The food industry also relies on surface area calculations. Ice cream cone manufacturers need to determine how much edible material, like waffle batter, is required for each cone. A typical waffle cone has a top radius of 3 centimeters and a height of 12 centimeters. The manufacturer needs to calculate the surface area to determine batter requirements per cone. First, we find the slant height. Then we calculate the total surface area using our standard formula. Each cone requires 145 square centimeters of waffle material. For a daily production of 10,000 cones, the factory needs approximately 14.5 square meters of waffle batter coverage. In industrial construction, conical silos and hoppers require precise surface area calculations for material estimation and cost planning. A grain silo with a conical bottom section has a radius of 5 meters and a height of 4 meters. Engineers need the surface area to calculate steel plating requirements. These examples demonstrate how cone surface area calculations are essential across multiple industries. From manufacturing and construction to food production and industrial engineering, this mathematical concept has widespread practical importance. Understanding how to calculate cone surface areas enables professionals to make accurate material estimates, control costs, and ensure project success across these diverse fields. Now that we've worked through several examples, let's review some important tips and common mistakes to help you master cone surface area calculations. First, let's discuss the most common mistakes students make when calculating the total surface area of a cone. The most common mistake is forgetting to calculate the slant height when you're only given the radius and height. Remember, if you have a cone with radius 3 and height 4, you cannot directly use the surface area formula. You must first calculate the slant height using the Pythagorean theorem. L equals the square root of h squared plus r squared. Another common mistake is mixing units. If your radius is in centimeters, but your height is in meters, you'll get an incorrect answer. Always convert all measurements to the same unit before calculating. This ensures your final answer will be in the correct square units. Now, let me share some important tips that will help you succeed with cone surface area problems. First tip, always draw and label a diagram of your cone. This visual representation helps you identify what information you have and what you need to calculate. Second tip, always double-check your calculations, especially the slant height computation and your final surface area result. Third tip, remember what each part of the formula represents. Pi r squared is the base area, and pi rl is the curved surface area. It's crucial to understand that our surface area formula has important limitations. Our formula TSA equals pi r times r plus l only applies to right cones, where the apex is directly above the center of the base. For oblique cones, where the apex is off-center, the calculation becomes much more complex and requires advanced techniques beyond what we've covered today. Let's wrap up with the key takeaways from our study of cone surface area. Remember the total surface area formula. TSA equals pi r times the quantity r plus l. This includes the base area pi r squared plus the curved surface area pi rl. When you're given the height instead of the slant height, always calculate L using the Pythagorean theorem first. Always draw diagrams, check your units, double-check your calculations, and remember this formula only works for right cones. That concludes our comprehensive study of cone surface area. If this video helped you understand the concept, please give it a thumbs up. Leave a comment if you have questions or suggestions for future topics, and don't forget to subscribe for more math tutorials. Keep practicing and you'll master these calculations in no time.